Determine the magnitude of the projected component of f along AC. Express this component as a Cartesian vector. And then also we want to determine the angle theta between the pipe segments BA and BC. So this angle theta. Well, we can use the dot product for both of these. Let's first get the component of f in this direction. So we need the unit vector in direction CA. So to do that, we need to start by getting the position vector RCA. In the x direction, we've got positive 7, so we'll do, it's minus 7 I hat. And then the y direction, plus 6, so minus 6 j hat. And then z, it goes, it's minus 4. Okay, so now the magnitude of this vector, we've got 49 plus 36 plus 16. So square root of 101. Okay, so now the unit vector in the CA direction is equal to, so we get now minus 7 divided by minus 0.697. Okay, minus, so minus 6 divided by, okay, 0.597. Okay, and then for 0.398. So that's the unit vector in direction CA. We want to get the projection of this force on the CA but the actual force vector as well. So how do we do that? Well, the force, the vector F in the CA direction is F dot UCA times UCA. Right? You get the this gives you the magnitude of that projection, and then you just multiply it times the unit vector. Right? We talked about this in the force vectors video. Okay, so multiply, well, let's take the dot product of F and UCA. So that's going to be what? 30 times minus 0.697, and then minus 45 times minus 0.597, and then plus 50 times minus 0.398. Okay, minus 13.9. Okay, actually this should be plus, right? We go minus 7, minus 6, and then plus 4. So this would be plus. So, okay, 30 times minus 0.697 minus 45 times minus 0.597 plus 50 times 0.398. 25.9. Okay, so we've got 25.9 UCA. So, okay. FCA, like this is 25.9 is the magnitude of FCA. But if we take, so 25.9 times minus 0.697 minus 18.1, okay, and then minus 15.5. And then $10.3, and that's FCA. So now we just need to determine the angle between the pipe segments. How do we do this? Well, we can use the dot product again. If we just get RAB and RBC, I mean, it would be easier if we just used unit vectors, a unit vector in the AB direction and a unit vector in the BC direction. Then we could use the dot product and get the angle easily. So let's do it like this. We're going to have a vector, a unit vector in this direction, and a unit vector in this direction. And we'll just use the dot product to get that angle theta. So what is RBA? Well, A is at the origin, so so we can just see visually it's minus 3 I hat minus 4 j hat, and that's it. Okay, so the magnitude of RBA is 5, right? 16 plus 9 is 25. So U hat BA is we just divide this by 5, right? Okay, so RBC now is what? Going from B to C, so CX is, well, we can look at it here, okay? We go minus 4 in the X, okay? And then we go minus 2 in the Y, and then we go positive 4 in the Z. Okay, so 16 plus 4. No, 16 times 2 is 32 plus 4 is 36. Square root of 36 is 6. Okay, so U hat BC is equal to, so minus 4 divided by 6 minus 2/3 minus 1/3 plus 2/3. Okay. So now let's take the dot product of UBA and U hat BC. That is minus 3/5 times minus 2/3 is 2/5, and then so plus then minus 4/5 times minus 1/3 is 4/15. Okay, so this is 6/15 plus 4/15, 10/15, 2/3. Okay, so we know that what is U hat BA dot U hat BC? It's the magnitude of U hat BA times the magnitude of U hat BC, which is both 1, cosine of theta, the angle between the two vectors, is equal to the dot product, is 2/3. There you go. Theta is equal to what? Cosine inverse cosine 2/3. Okay, I think I messed up somewhere. Let's see. 3 minus 4 minus 3 I hat minus 4. Yeah. Yeah, minus 3/5 minus 4/5. Okay. Then from, okay, yeah, I did. Why did I do this? going from B to C. I went from C to B, not B to C. So it's really plus 4i hat plus 2j hat minus 4k hat. Okay, so then this is plus minus. Okay, now here we've got minus 2/5 minus 4/5. Okay, so this is minus 6/15 minus 4/5 minus 10/5 minus 2/3. So this is, okay. So let's do this again, but put a minus here. And there you go, 131.8 degrees. You see where I messed up? I put, for some reason I put, we wanted U hat BA and U hat BC, but I did it U hat CB. So that angle, that 45 point something angle, was this angle, right? That would be 180 minus 131.8. See?